In this example, we're going to look at solving a problem using a system of three variables. So we have an application setting here. Marvin and Juanita, they are pooling their loose change together to buy snacks on their coffee break. One day, they went to the store, they spent $6.75 on one carton of milk, two donuts, and one cup of coffee. The next day, they spent $8.50 on three donuts and two cups of coffee. On the third day, they bought one carton of milk, one donut, and two cups of coffee for a total of $7.25. On the fourth day, they have a total of $6.45 left. Is this enough for them to buy two cartons of milk and two donuts? All right, now I know this is a silly problem because you'd go to the store and the prices would be there and you could just read the prices and add them up. But we have to do a really basic, simple example to help us figure out how we could apply this to a more complex setting. So let's think about solving this problem with minimal grit between our teeth. So what is the question here? Well, we want to know if we have enough to buy two cartons of milk and two donuts. We have $6.45 left. What we don't know the cost of is the price of a carton of milk, the price of a donut, as well as the price of a cup of coffee. So those are my three unknowns. I do not know M, milk, D, donuts, or C, coffee. And since I have three variables, that must mean I need to create three equations. The good news is I have 3 days worth of data. So let's look at each line here and see if we can create an equation. On day one, we have a total amount. They spent $6.75 for one carton of milk, two donuts, and one cup of coffee. Using these variables, we can write the equation M plus 2D plus C equals $6.75. On the next day, we spent $8.50 for three donuts and two coffees. So 3D plus 2C equals $8.50. On the third day, we bought one milk, one donut, and two coffees for $7.25, which gives us the equation 1M plus 1D plus 2C is $7.25. So now I have a system of equations with three variables. And in order to solve a system of equations in three variables, we use the elimination method to create two equations in only two variables. What you'll notice here is my equation in the middle is already missing M. So I already have an equation with just D and C. That means I'm going to use my top red equation and my bottom green equation here with some scalar multiplication and add or subtract them from each other in order to eliminate M. So I'm going to line these up. If I choose to multiply one of my equations by -1, then we'll have the opposite signs and the M's will cancel. So that multiplication creates this equation -M minus D minus 2C equals -725. So I'll add these together. My M's will cancel. 2 minus 1D gives us 1D. And C minus 2C, 1 minus 2 is -1C. And the difference of 675 and 725 is -0.50 cents. So it's -50 cents. So if D minus C equals -0.5. So now I have one equation with D and C, and I already was given this blue equation, which is 3D plus 2C equals 8.5. So I've got two equations in two variables, and I've listed them together down here. Now, I need to determine a scalar multiple. I could multiply by -3 or by +2. And since these are already opposite signs, I'm going to choose to multiply this bottom equation by +2. That gives me 2D minus 2C equals -1. So let's look at what happens when we add these together. I have 5D engineered so the C's cancel, and I have 7.5. That lets us know that D is 7.5 divided by 5, or rather 1.5. That means that donuts cost $1.50. D equals 1.5. Well, we also need to know what coffee and milk cost. So I'll use one of my two equations in two variables. I'm going to look at D minus C equals -0.5. D minus C equals -0.5. That means 1.5 minus C is -0.5. And then, looking at this, I'll subtract -1.5. I'll take that away from both sides. So I have -C equals -2, or rather C equals 2. So that means coffee, 1 cup of coffee, costs $2. Then we just need to know how much a cup of milk costs. And we can use either this red or green equation to determine the cost of milk. Since we know here we had M plus D plus 2C was equal to 7.25, I'm just going to plug those values in. M plus a donut, 1.5, plus 2 times 2 equals 7.25. M plus 1.5 plus 4 equals 7.25. M plus 5.5 equals 7.25. Subtract the 5.5 and we get that M is equal to 1.75. And that indicates to us that milk costs $1.75. At this point, I know what D, C, and M, the value of one donut, 1 cup of coffee, and 1 carton of milk are. Let's think about what our question originally asked us. Coming back up to our problem, the question says, on the 4th day, they have a total of $6.45 left, and asks, is this enough to buy 2 cartons of milk and 2 donuts? Well, we know the price of each. We can say that 2M plus 2D will be the cost of what we want to buy that day, or rather 2 times 1.75 plus 2 times 1.5, and we determine what that equals. So that would give us 6.5, or that would mean our total is $6.50. And the question is, do we have enough money left? And the answer is sadly, no. Marvin and Juanita will go hungry that day. So I hope that helps you understand how we would use these systems of equations to set up a much more complicated problem with many more variables. You wouldn't have to do anything more than something like this by hand in this class, but these concepts, they carry through to all of your future math classes.